Hello viewers. So yeah, I was very excited to upload this video. So today we are going to discuss about the Codeforces educational round 1082 solutions. And to be honest, this contest was kind of difficult. Like there relies a deep knowledge of, I would say, deep knowledge of how you try to prove things like uh when I was solving the first question. So it took me time to prove why my solution is correct. Because see, whenever you are during a contest, it's not always necessary to prove your solution. If you have practiced a lot of questions, then I would say that yes, it's like you are good to go. You can uh, submit your solution, but still, if you are not very much sure about your solution, then please don't submit it. But to be honest, proving your solution during contest is not a good move, because you will waste a lot of time. But still, if you think that yeah, your solution can be correct, then you should just submit the solution or submit the code. Okay, so I will start with the first question, and I will try to explain you with proofs. So please try to understand. And if you are not able to understand, you can put the comments. And if you don't want to put the comment, then you can pause the video and watch it again. I think that you will be able to understand. Okay, so uh, let me share my screen. So I hope my screen is visible. Let's go to the first. Wait, it's being recorded. Okay, so yeah, okay, it's being recorded. Cut the array. So you are given an array of n non-negative integers. These are the elements. Your task is to cut it into three non-empty parts, a prefix, a middle part, suffix. Okay. Formally, you need to choose two integers L and R such that okay, L is less than R, and yeah. Okay, so basically you have to obtain three parts by choosing two such integers. The prefix of the element at index L, okay, from A1 to AL. The central part from the element at index L plus 1 to the index at to the element at index R. Okay, AL1 plus AL plus 1 to LAR, and the suffix, of course, from R plus 1 to N. Okay. Okay. So these are the segments that you have to make. Now let S1, S2, S3 be the remainders of the sums of three parts modulo 3. Okay, so S1 is summation of A1 to AL modulo 3. Similarly, S2 is this, S3 is this. Okay, so I think up till here, there was no problem in understanding what the question says. Your task is to find such boundaries L and R such that either all numbers S1, S2, S3 are different, or all numbers S1, S2, S3 are same. Okay, okay. So one thing is sure that yeah, what is the possible values of S? Either it's 0, either it's 1 or 2. Okay, because of course it's modulo 3 and first line. Okay, so yeah, in each test case you will have an integer n and elements of the array. Okay, so how will we go about it? Before coming to the solution, let me tell you one thing, that I will stop sharing this question screen, and I will go to my whiteboard, or I would rather say blackboard, and you have to open this link on your laptop. And if you have any doubts in the problem or question, you just go to the link and see from there, because I'm not going to come to this URL again. String whiteboards. Okay. Okay, I hope so. My screen would be visible. That's it. Okay, so basically we have to break this. Wait a bit. Mm, yeah, we have to break this array into three segments: S1, S2, and S3. And if we calculate the modulo of each, then let's say it's giving you A, it's giving you B, and this one is giving you C. So either A is equal to B is equal to C, or A is not equal to B, B is not equal to C, and A is not equal to C. It means all three are different. So if one is claiming this statement, what does it mean? That A, B, C is a permutation of 0, 1, and 2. In other words, all A, B, and C are different, and they are one of 0, 1, or 2. Okay, they are among 0, 1, or 2. And if they are same, they could be either 0, 0, 0, or 1, 1, 1, or 2, 2, 2. Okay, this is my first observation. Now, what is my second thought? Let's say that you found a valid index L, comma R. So your S1 is from A1 up till AL, and you will sum all these, and then %3 will be your S1. Okay, let's say S2, it's AL plus 1 up till AR, and then you modulo 3, do modulo 3. Similarly, for S3, you are doing AR plus 1 up till AN, modulo 3. And let's say that this is some valid, uh, this is some valid blocks or segments, I would say. Okay, valid partition. So what is a 100% true fact about every valid partition? Either S1 equals S2 equals S3, or S1, S2, and S3 all are distinct. Okay. So if they all are distinct, okay, first we will talk about if they all are equal. So what would it mean? That S1 plus S2 plus S3 is what? S1 plus S1 plus S1, or S2 plus S2 plus S2, or S3 plus S3 plus S3, which means 3 times S1. Okay. And if it is 3 times S1, then I'm damn sure that this is 3 times S1 modulo 3 is 0, because it is divisible by 3. The sum of all the segments, which means that if you sum elements of arrays like A1 plus A2 plus up till AN, this will be this should be divisible by 3. Okay. If it is not, then you don't have any valid index. And if you don't have any valid index, then what do you have to print? 0, 0. This will be your L, this will be your R. Okay. So we are damn sure about this thing. Okay. Now, other thing. Let's say it's divisible by 3. So we would have some segment S1, we would have some segment S2, we would have some segment S3. And yeah, one more thing. You can just sum all S1 and then do modulo 3, or you can do modulo 3 first, like A1 modulo 3 plus A2 modulo 3 plus up till L modulo 3, and then do again modulo 3. Okay. So this won't make any difference. I think that you are not getting confused up till now, because everything was interesting and understandable. So let's say that it's some valid sequence. So what would be S1? Either they would all be equal, or they would be different. Okay. So I am just trying to explain you one thing. Let's say that I reduced the size of this segment to, let's say that its length was X, its length is Y, and its length is Z. Let's suppose this. So you want to reduce this size by 1. Let's suppose this thing. You reduce this size by 1, and let's say that here was some element D, which is uh some modulo 3. Okay, some AI modulo 3. Okay, you can also say AI, but ultimately we are going to modulo all the elements. So that's why I'm saying AI modulo 3. So did it change S1 if you reduce this size? It didn't. So S1, let's say that new segment is S1 dash, S2 dash, and S3 dash. So this is equal to S1. It didn't change. This is equal to S2 minus D, and this is equal to S3 plus D. And I would say percent 3, and I would say percent 3 here. Okay. Now I'm going to prove you this, that if this was a valid segment, S1, S2, S3, then this is also a valid segment. This is also valid. I'm going to prove it. Let's say that S1, S2, S3 were distinct, like they were not equal. S1 was 0, S2 was maybe 1, S3 was 2. Let's say this was the uh, values. Okay. So S1 remains 0, and yeah. So now I'm going to tell you one thing, that let's say we are also making one case, like 3 cases. D was 0, or D was 1, or D was 2. Okay, we will make 3 cases. So S2 minus 0, either 1 minus 0. Okay, S2 is 1, so 1 minus 0, percent 3, it still remains 1. And S3 was 2, so 2 plus 0, percent 3, it still remains 2. So 0, 1, 2, no change. Let's say S1 is equal to 0, and okay, this configuration is same: S1 0, S2 1, S3 2. Now let's say that D is equal to 1. So how would it change? S1 will still remain 0. S2 which was 1 will become 1 minus 1 0, 0% 3. 1 minus 1 0, 0% 3 is 0. And S3, which is 2, 2, and D is equal to 1. So 2 plus 1 3, 3 plus 1 3, 2 plus 1 3, 3% 3 is 0. So see, all became equal. So still it's a valid. Can you see that? It's still a valid solution. It's still a valid solution. Why? Because for a solution to be valid, either all segments are unequal or all are same. So see, we got a same value. Case 3, when D is equal to 2, then S1 is still 0, S2 is equal to 1 plus 2, 3, Okay, sorry, my bad. So it's 1 minus 2, 1 minus 2 modulo 3, and S3 is, and why I'm reducing it 1 minus 2, because yeah, of course, you removed one segment from D, so it got removed from S2 and it got added to S3. So 1 minus 2 modulo 3, and S3 is equal to 2 plus, what was S3? Yeah, 2 plus 2 modulo 3. So what's your S1? It's 0 minus 1 modulo 3, which is, I guess, 1 minus 2 plus 3 modulo 3. These are same, if you know the concept of modulo. So 1 minus 2 modulo 3 is same as 1 minus 2 plus 3 modulo 3. So 3 minus 2 is equal to 1, 1 plus 1 is equal to 2. So 2 modulo 3 is 2. And what about S3? 4, 2 plus 2, 4 modulo 3 is equal to 1. See, they are again different. So this is when S1, S2, and S3 were distinct, 0, 1, and 2. Now, this was case 1. Case 1, all are distinct. Now, I'm going to the case 2 if all were same. Let's say all were 0, 0, 0, or you could even consider it 1, 1, 1. It doesn't matter. Now, I will show you if D is equal to 0, then S1 will remain 1, S2 will be 1 minus 0 modulo 0 modulo 3, which is 1, and 1 plus 0 modulo 3, which is also 1. Now for D is equal to 1 case, 1 minus 1 0 modulo 3 0, 1 plus 1 2 modulo 3, which is 2, and 1, uh, why I did add this thing. Wait, yeah, I did a mistake. So this remains, S1 will always be 1, because we didn't change anything here. So this will be reduced by 1. 1 minus 1 0 modulo 3, which is 0, and 1 plus 1 2 modulo 3 is equal to 2. I think that you are able to understand why I'm reducing it from segment S2 and adding it to segment S3, and why we are not changing S1, because we didn't cut any part of segment S1, we just cut part from S2, which got added to S3. So it will be increasing, this will be decreasing, and this will be constant. Okay. And for the D is equal to 2 case, for D is equal to 2 case, similarly, S1 will be 1 and S2 will be 1 minus 2, which is minus 1 modulo 3 is equal to minus 1 plus 3, 2, 2 modulo 3 is equal to 2, and S3 will be 1 plus 2, 3, 3 modulo 3 is equal to 0. See, again they are same. I mean, different. So, what did I just prove? What did I just prove? I proved that if there is a segment S1, S2, S3, and let's say that its length is X, its length is Y, and its length is Z, then if you reduce the size of this by 1, and if this was a valid solution, first we uh, we have to know that this was a valid solution. Okay, considering that this was a valid solution, if you reduce the size of S2 by 1, which will be added to S3, then still the solution will be valid. And if you reduce, let's say that you reduced it by 1 and it was increased by, S3 was increased by 1 and this was constant. So now this S1 dash, S2 dash, S3 dash, now these are also valid segments, valid partitions. So we can apply the same rule here also. If I reduce the size of this by 1, which will be added to S3 dash by 1, then still it's a valid partition. So you just, I think now you know what I'm trying to say. I will reduce the size of S2 to 1. It means that length of S2 will be 1, and then I will have some suffix and I will have some prefix, and I will check that if S1, S2, S3 is a valid partition, and if I didn't get valid partition in the array, then I will simply return 0, 0, 0. Else I will return the left part and the right part. I think you understood. Now I will just go and code. Okay, let me. So yeah, the screen visible. Hope so. So yeah, first we have to input our vector. So so this will be our V. Okay. Now I will take a prefix vector and a suffix vector, and then I will make prefix and suffix vector. I hope that why you are understanding that why I'm making this in order to get the prefix and suffix remainder, or you would say suffix sum modulo 3. Okay, because our middle segment length is always going to be 1, so that we can simply calculate our answer. So if I equals 0, then our prefix of I is equal to vi modulo 3, and our suffix of n minus I minus 1 is equal to v of n minus 1 minus I modulo 3. Else, it's totally different case. I'll just do this prefix of I minus 1. Either I will do modulo 3 here, or I will first do the sum and then do modulo. Doesn't make any difference. And suffix of n minus 1 minus I plus, I would say, yeah, this modulo 3. So yeah, I could calculated this. Now I'm going to start from I is equal to 1 less than n. Yeah, okay. So I think you can understand that why am I trading from I is equal to 1 to I is equal to n minus 2, because our middle part can be either the second index, if I am talking about the first one based indexing. Okay, so it can either start from second index and go up till second last index. Okay, because it's the middle part. Now at each index I will just check if, or I would rather make int a is equal to prefix of I minus 1, int b is equal to suffix of I plus 1, and int c is equal to current index modulo 3. So if they all are equal and b is equal to 3, if this is the case, either they are equal or they are distinct. A is not equal to b, and then b is not equal to c, and a is not equal to c. If this is the case, then I will simply return my L is equal to 0. First, let me initialize this. I will simply uh, put L is equal to I, R is equal to I plus 1. Why I'm saying I? Because I is the previous index. I cannot say I minus 1 because it's 0 based indexing. So I will have to do this. So that's why I just put L is equal to I. And your R will be I plus 1. Okay, you got it now. Current index, and I'm adding 1 because it's 0 based indexing. and we want answer in one based indexing. And then I'll just break. Okay. And then I will simply do this. Now this solution should work. So wait, was not declared. V was not declared. Vector. Okay, the spelling of vector is wrong. So yeah, I think this solution should work. Now let's move to the second problem, B part. Let me share my whiteboard again. Or wait, let me share the question. Okay, so I hope that the screen is visible. Question A, problem A was, I think, easy to implement, but difficult to explain you. Not difficult to get, but difficult to explain, I guess. Okay. Recall that a permutation of length n is a sequence. Okay, so yeah, I think the first line is understandable. It's basically a permutation definition. Okay, let's define the cost of a permutation as the minimum length of its contiguous subsegment that needs to be sorted so that the entire permutation becomes sorted in ascendant order. Okay. You are given an integer array P consisting of integers from 0 to n, where no positive integer appears more than once. You should replace zeros with integers so that the array P becomes a permutation. Okay, so basically you will have some arrays, some elements in the arrays, and uh, basically uh, you have to choose some contiguous subsegment. Like contiguous means that you have to choose a segment, let's say from L to R, and if you sort that segment, then the whole permutation will be sorted. So basically, you have to, yeah, choose that segment. Now, what is our task? Our task is to calculate the maximum possible cost of the resulting permutation. And what is the cost? Cost of a permutation is minimum length of its contiguous subsegment that needs to be sorted. Okay. So let's take an example from the test case. This test case. See, 1, 2, 3. So yeah, one more thing that I forgot to tell. You are given an integer array P consisting of integers from 0 to n, where no positive integers appears more than once. It means that if any integer which is greater than 0, like 1, 4, so it will not appear twice. It will appear once. And if there are zeros, they can be more than one, like more than one time. So you should replace zeros with integers so that the array P becomes a permutation, which means that you have to select these elements which are 0, and you have to put some elements such that this becomes a permutation. For example, if I put a 2 here and a 3 here, okay, so hmm, if you put a 2 here and a 3 here, so yeah, it's a permutation. If you put a 3 here and a 2 here, it's again a permutation. But if you put a 3 here and also a 3 here, then it won't be a permutation. Okay, so yeah, see, I'm going to take this two test cases and going to explain you the problem. Okay, so now again, I would say that I won't be coming to this URL again. I'll share my blackboard, and yeah, if you have to see the problem again, you can pause the video and go to the problem, read the problem, come to the video again and play the video. Okay. Yeah, I think now my board is visible. So this is the problem B. And first I will try to explain. Okay, wait. Let me now. Okay, problem B. So first I will take two test case. First test case 10405. 10405. Okay, so first let's focus on making this a permutation. Okay, first let's focus on that. Then we will try to maximize the cost. Okay, so how it can become a permutation? 1 2 4 3 5. Okay, or 1 3 4 2 5. Is there any other way to make this up, to create a permutation? No, because you can't choose 4 here because it's already there. Okay, now if I ask you the cost of this, what will be it? Will it be 2? Why? Because cost is minimum. The definition of cost is minimum length of its contiguous subsegment that needs to be sorted so that the entire permutation becomes sorted. See, this is sorted because at the first position we have 1, at the second position we have 2, but at the third position we don't have a 3. So this needs to be replaced. And I hope that you know one fact that in a permutation P, if you sort it, it will become just like 1, 2, 3, 4, 5 up till n. It will be a natural number. Okay. So here it should be 3, but it's not 3, it's 4. And here it should be 4, but it's not 4, it's 3. So can I say that if you just choose this segment and sort it, then the whole permutation is sorted? Because uh, other than these two segments, all are at their correct position. Okay, but wait, if we chose this as a permutation, then I would say that the length should be 3. Why? Because the first position where your vi, I'm talking mathematically, is not equal to I, is at 3, and the last permutation where vi is not equal to I, is equal to 2, is not equal to I, is this index, this particular index. So if you sort this, then the whole permutation is sorted. Simple. So I think you got the idea also what I was trying to say. We have to make the first our task is to make the permutation, and then we have to select one such permutation which gives us the maximum cost. Okay, and you can never reduce its length. It will always be 3. Why? Let's say that you choose this length, then this will be not sorted. Okay, like you will have to choose this length 3 to in order to sort this array. Okay, so okay, let's say that there were no zeros in the array. You know, this 0 is making the problem interesting. Otherwise, you know what's the answer? Let's say that there were no zeros in the array. Then you have P1, P2 up till okay Pn. Uh, so you would choose from starting, you would go and choose such I which is not equal to Vi. Okay, minimum index which is not equal to Vi, and then you go from here and you find maximum index which is not equal to Vi. And if you get the minimum index, let's say mini, you get the maximum index, let's say maxi. So basically length of this is your answer. So what is that? Maxi minus mini plus 1. I think that you are able to understand at least this. Okay. There was no rocket science in this, because of course the minimum index which is not equal to vi, you will have to change it. You cannot just keep at that place only. And the maximum index also you cannot change. And why I'm just going to find the minimum, why I'm finding minimum and why I'm finding maximum, in order to get the maximum cost. Of course, if you just go or at some random index and find, you like, how are you so sure that before that index everything's fine? No. So that's why I have to go from left to right, then I have to go from right to left and get this thing. Okay. Now everything was, I think, fine up till here. Now comes the interesting part. Zero. Why zero makes the problem interesting? In the second test case, why I was talking about that, I will explain you first two test cases because it's needed. Without that, I cannot explain you. So second test case is 0, 0, 0. Now it's up to you how you define this permutation. If you just make 1, 2, 3, then I would say that you are the dumbest person in the world. Why you would like to like make an array which is already sorted? Why? Why the hell would you do it? Will you do 1, 3, 2? If you do this, then also you're the dumbest person. Because if you have the option to create a permutation which gives you the cost 3, then why would you make such permutation where this vi is already equal to I? See, whenever I find a 0, I would always try to make it not equal to I. If it's at index I, suppose that it's at index I, why would I try to sort it? I just want to mess the array. I don't want sorted array. I don't. So the best would be 3, 2, 1, or 3, 1, 2. These both are fine. Why these both are fine? Because I don't care. Here in this case, vi is equal to I, but here vi is not equal to I. So I will have to choose this whole segment anyways, because this is not at its correct place and this is not at its correct place. Similarly, this is not at its correct place and this is not at its correct place. So I will have to choose this. Okay. So yeah, I'm going to tell you a very interesting thing now. Let's say you have only, you will count number of zeros in a count variable. Okay. And if it is 0, it means that you have no zeros. Then your answer will be simply uh, what I was explaining you. Go from left to right, find the first index which is not equal to vi, and then you go from right to left, find first index which is not equal to its vi, and then you just get the length. Another thing, if count of 0 is equal to 1, it means, you know what it means. It's similar to this thing if you observe carefully, because you don't have any option. You don't have any option. And why I'm saying you don't have any option, let's say that you have P1, P2, and some PI, then uh, PN, okay? And let's say that it's 0. Then would you have any option to fill this? You are forced to fill whatever is not present in this permutation. Let's say that 7 is not present. So you are forced to fill 7 here. You cannot put 6, because if you put 6, then it's already present in the array and you will just mess this permutation table. Sorry, permutation array. So you are forced to put this 7. So if you ever find count of 0 is equal to 1, you just uh, complete the permutation by putting the suitable element, and then you do this thing, not this thing. Wait, wait. Yeah, this thing, maximum minus minimum plus one. You do this thing because it's same as count is equal to zero. Count zero is equal to zero. Now comes the next case, count zero is equal to two, or I would say greater equal to two. Now you have a permutation pi pn. Okay. Now you know you will still try to find minimum index which is not equal to I. This fact is not going to, not going to change. This will be universal, because if any element which is not at its correct position, you will have to put it at its correct position. Okay. But if you know encounter a zero in that case, then also what you would at that position, what you will fill. See, if you have two zeros, wait, let me explain you in this way. 3 0 4 0 1. Okay. So I'm just trying to say that if you have two zeros, then you always have the power to put wrong elements at that place. If you had 1 0, then you are forced, but now you are not forced. Suppose that this is the index 2, then you will put 3. Oh, sorry, not 3. Okay, let's say that we have to fill 2 and 5. Yeah, these two are missing, so you will put 5 here and you will put 2 here. Okay, what I'm trying to say is that you just put wrong values at 0, like wrong index. Okay, the index which should not be here, you will put those, and you have the power. If you have count 0 greater equal to 2, you always have the power to put wrong elements. Okay, so now what you will do in this case? In this case, you have to just find one thing. If vi is not equal to I, if this is the case, then similarly, as simply I will uh, store this uh, index in the mini variable and break. Similarly, I will go from right to left, and if vi is not equal to I, even if it's 0, I don't care, because I can put wrong element at that position. I'll store it in maxi, and then similarly break. My answer will be maxi minus mini plus 1. Okay. Now I will show you the code. It's during the contest, I was not, able to write the very good code, but still I will show you. Let me share my screen. Okay, wait a bit. If it's take if it takes time, then you can simply uh, move 20 or 30 seconds forward. Okay, there's no problem in that. I will show you the accepted solution. Okay, so this was my solution I did during the contest. So first I will just initialize this vector, and I will initialize this count zero variable. Some variable I will tell you why I'm doing this. If vi equals to 0, I'm just adding the count, how many zeros are there, and I'm just adding elements. Okay. Now, if count 0 is equal to 0, then I will just make this variable mini and maxi. Why I'm putting n plus 1? Because I have to find minimum index. Well, it's not required, but still, yeah, I just did it. Now you go from 1 to n. If vi is not equal to I, you find the first index which is not equal to vi. You store it in mini, break this. Okay. Now you go from right, first index which is not equal to element vi, and store it in maxi. Now, if mini was equal to n plus 1, which means that mini never changed, which means that the array is already sorted. So, yeah, you will print 0. And if not, then maxi minus mini plus 1. Now, in this case, if count 0 is equal to 1, it means there is one element which is missing from the permutation. We have to fill that missing part. So, this is the total sum of your permutation, because your permutation contains 1, 2, 3, 4, 5, 6, 7 up till n. So what will be the sum? N into n plus 1 by 2. Okay. You might have read this in your 11th class in sequence series. And what's the remaining element? Left one. Left means the remaining element, the one element that needs to be filled with. So total sum minus sum of the array, because your array has one element missing, and uh, except that element you have 0, so that element won't be added. So total minus sum will be your the element which needs to be added. Now I iterate from I is equal to 1 to n. If vi is equal to 0, I assign vi is equal to left. Okay. Now you have the permutation array. Now what I'll do, max, same thing. I'm going to do same thing. Okay, that I did if count 0 it was 0. Else, if count 0 is greater than equal to 2, then what are you going to do? I think the same thing. Same thing. If vi is not equal to I, even if it's 0 or anything, if vi is not equal to its permutation, then you will store that index. Why? I'm saying that even if it's 0, because if it's 0, then of course you will put wrong element at that position. And let's say that you got an element, let's say that it was not equal to 0, vi was not equal to 0, but it was some random number, like let's say 3. So then also you will break it. What I'm trying to say is that there is a competition between 0 and some random element. If 0 comes first, then I can for sure put wrong element at that position. And if there's not 0 and some random element which was at wrong position comes first, then I have the full power, to assign many to that index. Okay. You I think are able to understand what I'm saying. And similarly for this maxi variable. Okay, I will go from n is equal to 1. Yeah. So this was the whole code. And yeah, I think you can just copy it, or you cannot copy it, you can just see. Now I'm going to move to the problem C, which was, I guess, difficult. Let me share my board. Okay, not board, but yeah, okay. We are going to discuss this problem C, which is the last problem that I am going to discuss. You are given two integer arrays A and B, both of length n. You can choose any subset of indices and swap the elements at those positions. That is, make a swap of AI comma BI. So basically you have two arrays and you can swap AI and BI, AI with BI for each I in the subset. So a subset of indices is considered good if after swapping, both the arrays are sorted in non-descending order, which means in ascending order. Okay. So if you are not able to understand the question, I will try to explain you with examples. So in each test case, we have integer n and then some elements. Okay. So, okay, let's consider this first test case. In the first example, there are two good subsets. Okay. How? 1 and 3, which means that if you swap 2 and 1, these two, then it will become 114 and this will become 232. So it's not up till yet sorted because 224, yeah, 114, this array was sorted but this wasn't. Okay. Uh, Now I'm going to explain you on the board. Okay. So again, I'm going to say the same thing about the URL. So wait a bit. Okay. So I hope my screen is visible. So I was explaining you the problem C. So array A was 3, sorry, my bad, 2, 1, 4. B was 1, 3, 2. And the subset, it was 1, 3, and it was 2. You know what this means? That if you swap these two indexes, then you will get sorted array. And if you swap just this index only, then also you'll get sorted array. So this is the meaning of this question, and I will explain how. So let's say that this is, let's say these are indexes 1, 2, and 3. So swap first index, which means swap A1 with B1. It will become 1, 2, 1, 3, 4, 2. So is it sorted? Yeah, A is sorted, 1, 1, 4, but B is not sorted. 2, then 3 is greater, but 2 is smaller than 3. Okay, now what it's asking, it's asking to sort even 3. So which means A3 with B3, which will become 1, 1, 2, 2, 3, 4. Now this is sorted. That's why it's asking you to swap these two indexes. And if you swap just second index from the original array, then how will it go? 2, 1, 3, 1, 4, 2. See, these both are sorted. Okay, so now we need to find how many number of subset are there. Let me again see the question. For each test case, print a single integer, which is the number of good subsets. Okay, taken modulo 998244353. Okay, so modulo is 998888244 which is not necessary to tell you this. You just have to take modulo this. And why is it asking to take modulo this? Because of course the answer could be a very big integer. Okay. Now, how can you find such like number of such subsets? How can you do it? Okay. Let me give an example. I will go with the third test case. 2 double 3 double 4, 2 double 3 double 4, and double 1 3 5 6. Double 1 3 5 6. Can I ask you one question? Yeah, there was a very, very, very important fact about this question. Very important, very important. If you miss this, then I think you won't be able to come up with a solution. And the important fact was there is at least one good subset. We have at least one good subset. Okay. So now I'm asking you one thing. If uh, this is true, like we have at least one, sorry about my writing, good subset, then let's say that Ci is minimum of Ai and Bi, and let's say you have some array D which is maximum of Ai and Bi. So my claim is that array C is sorted and array D is also sorted. And if it's not, then this fact is wrong. At least one of at least one we have one good subset. This fact is wrong. If this is not true, then this fact is wrong. And why I'm saying like that? Let's say that you have some array 1, 3, 2, 5, and you have 5, 2, 1, 6. Let's say this array. So minimum of 1 and 5 is 1. Minimum of 3 and 2 is 2. So 2, 1, 5. And maximum of 1, 5 is 5. Then we have 3. Then we have 2. Then we have 6. So my claim is that this is your array C and this is your array D. So whatever you do, you can never sort it because you got the maximum of these two elements to D. And even if maximum of these two element is, you know, less than the maximum of this, then do you think that you can ever sort it? My claim is no. Why? Because even if you swap this 1 with 5 and you will say that yeah, now this is sorted 1 3, but then this will be not sorted. 5 will come here. Why? Because maximum of AI comma bi. Okay, let me explain in another way. Because if 3, which was maximum of 2 comma 3, was less than maximum of 1 comma 5, which is 5, then even if you bring this C, which is less than 5, okay, Ci is less than, I'm saying Di. So this will be sorted 1 3. Now this will be sorted. But if maximum of 1 comma 5 was greater than maximum of 2 comma 3, so I'm damn sure that 3 is less than maximum of 1 comma 5, which is the previous index maximum elements, and 1 is less than 3, which is, sorry, not 1, 2. 2 is less than 3, which is this index. So if you try to, bring 1 before 3, then 5 will come before 2. Like, are you able to understand what I'm saying? If these C and D's are not sorted, and what is the minimum of AI comma BI at every index, and D is maximum of AI comma BI at each index. If they are not sorted, then you can never sort the array. You can never. That's my claim. And I was trying to explain you with, my full potential. Because what I'm saying that even if you bring this, the minimum one before this three, then maximum one will go there. Okay. And if maximum of, ci minus one, okay, let me explain you in this mathematical way. ci minus one, di minus one, and then we have ci and di. So if maximum of di minus 1 is greater than maximum of di, so maximum of uh, okay, maximum, not maximum of di minus 1, this is the maximum only. So if di minus 1 is less greater than di, so there is one thing that you can do. You just can claim, okay, I will swap these two and bring ci minus 1 to before di. Okay, now this is sorted. You can say that, okay, this becomes sorted. But then this maximum value di minus 1, which was greater than di, so will it not be greater than ci also? Because ci is less than di. And this is true because why it is true? Because you're saying that ci is minimum of ai comma bi, and di is maximum of ai comma bi at each index. ai comma bi at each index. So now was I able to prove this, that this can never happen? Because our question claims that there is always one good sub array. So is this fact true, that C is sorted and also D is sorted? Okay, this is my one claim. Now let's move to the second part of this question. How can we calculate number of good segments? Now I will ask you one question. Let's say that there is some index I which is restricting this whole array to be in sorted order. Then what is the, like, what you can do the least, or I would say that ज़्यादा से ज़्यादा आप क्या कर सकते हो? At most what you can do, you can just swap these two and 100% it will become sorted, because the question says that there is at least one good survey. So it can never happen that even after swapping these two, it's not sorted. Okay, that's what I'm trying to say. So you will sort it and then it will become sorted. So at any index I, you can either swap if it's not sorted. Like, not either, you can, you will have to, you have to swap if it's not sorted. And I'm going to tell you one more thing. Let's say that you have okay, na what the C means. C is minimum of ai comma bi, minimum of ai and bi, and your D is maximum of ai and bi. Okay, now you know this. Now I'm asking you this thing. At this index, let's say we have ci and di. Okay, and at I minus 1th index, you have ci minus 1 and di minus 1. Okay, and of course this is the maximum value and this is the minimum value, and in this also this is the maximum and this is the minimum. Sorry, this is the minimum and this is the maximum. So my question is that if di minus 1 is less equal to ci, what it means? At maximum value of I minus 1th index is less and equal to minimum value of ci, which is minimum value of ith index. So can I say that I can this will be my array, like let's say a dash and b dash. This will be my array, So I can, in my this A dash array, I can put at ith index either Ci or Di, because it won't change anything. It will still be sorted, because even the maximum value at the previous index is less than the minimum value at the next index. So even if you keep it like Ci or Di, or Di or Ci, it really won't matter. You are free to do this. You're free to do this. So can I say that these two blocks, uh, Ci minus one, Di minus one, and Ci and Di, these are different? Can I say this, that these two blocks are independent? Whatever you do with this block and whatever you do with this block, the array would be sorted. That's my claim. These two are independent. So let me, this question might, you might feel that this is very tough, but trust me, if you just understand it, you will understand the whole solution. Let's say that you have, like 10 such blocks, or let's say x such blocks, which are independent to each other. Some x blocks, okay, which are independent to each other. Uh, b1, let's say some bi, and then bx, okay. So all these blocks are independent to each other. So can I say that number of ways of this let's say number of ways to make this array sorted, let's say it's x. The number of ways to make this array sorted, let's say it's y, and let's say this is z, okay. So can you say that answer will be x into y into z? Can you, why I'm, putting quotation marks, I don't know. This will be your number of ways, because all of these are independent. And why I'm saying x into y into z, because let's say that you have x ways, you know in this box to make this array sorted. And how I'm saying x ways, let's say that you swap some integer I, or you don't swap it, or you swap some integer j. So you will have some subsets in this array, in this one, which will be independent to this block, okay. So let's say that you have um, some x ways or x subsets, I would say. So you will just multiply x into y into z. I think that you are able to understand. Okay, I hope what I'm saying you understand. So this will be your solution. And now the last part that remains is how will you find the number of ways? Okay, that is the last part. So up till now, I just told you, if ci minus 1, or not ci minus, di minus 1 is less equal to ci, then these two blocks are independent. So when they are not independent, when they are dependent to each other, when your di minus 1 is greater than ci, then you can never say that, yeah, I will do anything. I will either put ci in the ith index, or di in the ith index. No, you are forced to put either ci or di, ain't you? And I would say that you are forced to put this. See, if this is the case, then you will have ci minus 1, you will have di minus 1. And if di is greater than ci, then you can never put here di or ci. You will have to put di, and you will have to put ci here. And now I'm saying that this will be sorted. If it's not even sorted right now, then the fact that we have at least one good subset is wrong. So this will have to be sorted. So we will just have this one choice. Okay, one choice, that you have to put di here and not ci, because di minus 1 is greater than ci. So no, you can never put ci here. Now, is there only a one choice? My question is this: is there only one choice? No. Either you put di minus 1 and di here, or either you put both in the upward array, above array. So this is the second configuration, di minus 1 di and ci minus 1 ci. Okay, so this is the another way. So one more choice. Now can we say that we have two choices? And you know, this is the solution to the question. We have the total number of ways is 2 to the power number of blocks, number of independent blocks. Because independent blocks, we just have two choices. See, we just have two choices in the dependent blocks. You can never put anything in front of ci minus 1 or in front of di minus 1. You will have to put di here and you will have to put ci here. You don't have any option. You are helpless. And how will find number of blocks? Whenever we encounter di minus 1 greater or equal to ci, less or equal to ci, I will increase my blocks by 1. Increase my blocks by 1, or I would say segment by 1. Okay. Now I'm going to show you the solution. I don't think that I need to show it because it's super simple. If you understand the problem, then it's very simple. Where to code. Implementation part was not tough in any of the problem among A, B, and C. All were easy. Just every question was not that much, easy to understand. Yeah, so this is the simple solution. Initially, you consider the number of blocks or segment is equal to 1. And why 1? Of course, that if uh, have no such uh, di minus 1, which is less or equal to ci, then your array is already sorted and you don't have any choice also. So yeah, you just have one segment. Now I go from I is equal to 0 to I less than n minus 1 and check if maximum of ai and bi is less equal to minimum of ai plus 1 comma bi plus 1. And if it is, then this block is independent of this block. We can do anything with this and we will increase our segment by 1 and then power of 2 comma segment. Okay, this I have created this power function. This is my template and I put here mod 2 because in question we were asked to you know have mod as 998, this one instead of 189 plus 7. And if you want me to explain this function, like how this power is calculated, then you can just go to the CP algorithms website and look there. And yeah, this is very simple. So yeah, this was the whole solution. Now I'm also exhausted. If you like the video, just continue watching my coming videos also, upcoming videos also. And I will try to start the DSA playlist very soon. I'm also like occupied with some things, so that's why I'm not able to start right now. But yeah, I'm sure about one thing, that I will try to you know discuss contest solutions, like most of the contest solutions I will try to discuss. Okay, so yeah, that was all from my side. Let me come to the meeting.